All right, integrated 3 students, we are at the end part of our year. And in the lesson today, we're really going to be focusing on stats. And this is kind of how we're going to close out the year. We've got just a few more weeks left, and it's just going to be all statistics. I know several people are going to be taking pre-cal next year. That's sort of what the unit circle was all about, getting you ready for that. But I do have several people that are going to be taking stats with me next year. So this is sort of laying some foundations for that and just getting into that. Some of the IM3 standards, like this is stuff that we missed during the year, but we're going back to learn it. So we're going to finish out the year that way. Let's go ahead and get started. All right, so not going to be a delta math over this unit. And stats is a very different type of math. There's no doubt about that. It's just a different type of math. And a lot of it is very, I would say, you talk about a lot more things than you do solve equations and look at examples and talk about ideas. So the first thing we're going to do is we're going to start by writing down some definitions. So in your notes, you can, actually, let's do this. In your notes, I would say start a new page. And we're not going to say chapter 4 or anything. Just say designing studies is the topic. And then we're talking about samples and surveys in this lesson today, okay? Samples and surveys in this lesson today. So first thing we want to talk about are these 3 definitions. We have population, census, and sample. So I'm going to pause and you can go ahead and write those down. Okay, so when you're designing a study, the whole purpose of that is to gain information, okay? And the information that you're trying to gain it tells you something about the larger group of individuals. So we have what's called the population. This is the entire group of individuals we want information about. Now, it's very tedious to gather that information. Think about the entire United States. That's over 300 million people. It is very inefficient and expensive and time consuming, and it can have a lot of errors to conduct a census or poll everyone. That's what a census is, collecting data from every individual. I believe the census is every 10 years in America. Let me double check. Yeah, a quick Google. Every 10 years it is mandated by Article 1, Section 2 of the Constitution. Okay, the data collected by the decennial census determines the number of seats each state has in the U.S. House of Representatives. It's also used to distribute hundreds of billions of dollars in federal funds to local communities. So it's super important that we have that census. I believe the first census was back with the Romans, back when they used to do that. But really, you're just getting information about your population, okay? And it's very accurate information, especially if it's connected correctly. Now, on average, you're not going to be able to do that, okay? On average, we have to take a sample from the population. And a lot of times, that is good enough. You don't actually need everyone. You just need a sample that looks like the population, a small piece of it that is representative, right? To create I would say an accurate, I would say a statistic that can predict the population's value. Okay, so these ideas, this is probably the first time you've heard about these. You've done stats in some classes like data manipulation and graphing and stuff like that, but this is really the whole purpose of it. So let's look at this little diagram here. I need this to load for me. Quick. Okay, so this is what I wanted to look at. I guess it's not going to work. This is what I wanted to talk about here. Yeah, okay. So from the population, you're going to take a sample that is representative, and then you make it what's called an inference about the population. So these 2 statements here, like this collective statement, is really the essence of statistics and what it's all about. Those taking stats with me next year, we spend the whole year exploring the different aspects of this concept. We're laying down the foundations. If you take a stats class in college, or maybe one day you major in a field that has research done in it, like science, medicine, marketing, you'll have to learn these foundational skills. So that's really what we're doing today is just talking about it, and then next year, if you're taking stats with me, we really get the foundation established. Okay, so in Kidum, I have put up. I think I've put it up. Hold on, let's see. So in Kidum, you'll see this statistics, designing studies, sampling worksheet. You'll find that right there. You are to handwrite and upload a scan or a picture of these. Do not submit the HEIC, which is high quality image or something like that. I don't know. I think that's an iPhone thing. Don't submit it like that. If you are afraid of that, just download like a scanner app and upload it for me. But I have that happen all the time. I don't know what the problem is with it. But that would be this worksheet here. This is what it looks like, and this is what we're going to be looking at today. So this is where we're starting. In these examples, and I'm going to be working through this whole sheet. So this is more like guided notes, right? That's what this is, and you just are proving that you actually you looked at the lesson, and this is really what we're doing. I'm not going to have anything too strenuous for you guys to close out the year, but this is just showing that you're doing the work. So in each section here, in each part of this, you are to identify the population and the sample in each of the following. Okay, so what would be the population, which is the entire group we want information about, and then what's the sample? That's the subset of that population that we're using to gather data. So I'm going to pause the video here, and you guys are going to go ahead and answer both A and B. Okay, so let's go ahead and look at this. The student government at high school surveys 100 of the students at the high school to get their opinions about the change to the bell schedule. So I'll be typing this out. So the population and sample, and this is how you can answer these, by the way, and on your paper you can just put a population sample. Fine with me. It can be simple. We're not trying to complicate this. So student government at a high school, they survey 100 of the students at the school, okay, to get their opinion. That 100 would be what we'd call the sample, because it's not everyone. Imagine if this was at our high school. There's like 2,000 kids there. 100 is obviously not the whole 2,000. So this 100 is the sample. Now, who is the population? What are they interested in? Okay. Well, they want the opinions about the change to the bell schedule. They want all students' opinions. They want the general consensus about changing that. So the population is all students at the school. So the population is all the students at the school. We take a sample of 100 of those students. Okay. So that's going to be, that's what this is. Next, population sample. Quality control manager at a bottling company selects a sample of 10 cans. It even says the word 10 cans sample right there of those 10 cans. So it's from the production line every hour to see if the volume of the soda is within acceptable limits. Okay, so it's pretty easy to know that the sample is 10 cans from the production line for a given hour, right? It's not just 10 cans for the day, right? It's very specific, okay? And I'll say that. 10 cans from the production line for a specific hour. So you imagine there's this assembly line. You've probably seen the show How It's Made, where they have, like, they'll make little things that come out, and there's a lot of them, right? And you'll have people that sort of just take random samples. It's almost like this systematic sampling method here where they're trying to do quality control. It's very important. So what is the population here? Is it all the cans in the factory? Well, it wouldn't be all the cans in the factory, because you're only concerned about this hour's cans, right? So we're going to say all cans from the production line for a specific hour. All cans from the production line for a specific hour. That would be the population. Okay? All right. So that's sort of the beginning of this. We're identifying the population of interest that we want to ask the question about. We could do this at our school. Okay? Let's imagine, I'm going to pull back up the PowerPoint here. Imagine imagine that I am interested in our high school, Stewart's Creek High School. And what I want to do is I want to know what is the average height for the entire high school, where every student, doesn't matter gender, anything like that. We're just saying take all the students and we are going to find the average height. Okay. Let's say that I want my sample to be, let's say I just send out a survey to you all. Like, let's say I do it digitally, send it to you, and I do my in-person students as well. And I say, hey, give me your height. Okay. And when I do that, you all send your information back, and I average all the heights that I get. And I use that as my estimate, right? I'm going to make that inference, is what it's called. That's sort of like your, right now we don't have a definition for inference, but it's like a guess, right, for what truly is. So when I take that average height from all of you, my students that I just sent that to, hopefully you're understanding that there's a problem with me doing that. Okay, maybe you're thinking, oh, if he takes a sample from just his IM3 honor students, right, because that's who you would be, that would be my sample, there would be a problem, right? Because who is not represented? Right here it says I need a representative sample, because what would happen is the freshmen would not be in that sample. I don't have any freshmen in my IM3 classes. I do have some sophomores in there. I don't have any seniors, but it wouldn't be freshmen in there. So there would be what's called bias. Okay, there would be bias, and we're going to put a definition down for bias. But hopefully that makes sense. Is that the number I got from you all as my sample would not be good as an estimate of the population, because it's not representative. Okay, let's look at some definition or some more ideas here, because what that would be if I this yet? No, we don't care about that. All right. So what we're talking about here is how to sample badly, because that's what that was. What I did would be a bad sample. So draw a line in your notes and then write this title at the top. It says how to sample badly. And that's what the whole lesson is about, is how are we supposed to sample when we're designing a study. And by the end of our course, or of this unit that we're in, the stats unit, we need to have a better understanding about how this should work. Okay, so how do we sample badly? So it says, how can we choose a sample that we can trust to represent the population? Obviously, just taking you all, the IM3 students, is not going to be a trustworthy sample. That it doesn't represent Stewart's Creek High School, all students there, right? It represents all of Mr. Wood's IM3 students. That's it. Okay, so if we redefine our population, it might work. So there's another of different methods to select samples, but here are the bad ways to sample. So what I just did there is called a convenience sample. All right, so I'll talk about it, and then there's something that we'll write down this whole slide in a second, but if you want to go ahead and write as I'm talking, that's fine. But this is when you choose individuals from the population who are easy to reach results. Okay. And that's just because I know you guys, and I've had you all year. I have your emails. It's a convenient thing for me to just send that out and gather that info. But it's biased. So we have this other definition. It says convenient samples often produce unrepresentative data, because the design of a statistical study, it would show bias, because it's going to underestimate or overestimate the value we want. In our situation, it overestimated. You guys would be way too tall. Okay, that's just how it should be based on how heights work and how maturing and growing work, right? And I think we all know that. So that's the idea. Now another example of convenient sample would be, let's say that I wanted to ask the same question. And I said, okay, well, this time I'm going to stand in front of school. I want a more representative sample, right? I'm going to stand in front of the school before school starts, and I'm going to survey the first 50 people that come into the school building, okay? It could even be 100. I don't care. It doesn't matter the amount. But what's wrong with that first 100 or first 50, whatever the size is, that comes into the school? Well, they're probably going to be underclassmen, right? They're going to be freshmen. So like or sophomores that can't drive, like their parents are going to drop them off, because juniors, and I'll say because my in-person juniors, they usually get there, right before 8:30, if not within 5 minutes before. So those first 100 in the building, they're getting dropped off probably because they don't have their own car. Okay, so a lot of them are going to be underclassmen. There would still be some seniors and juniors, especially if they're getting off the bus. It would still happen, but overall, it would not be a representative sample. That would be a convenience sample. So I've sort of been going on a rant there for a bit. I'm going to make sure and pause here so you can write this. But there's one other type of biased sampling method. Let me move my camera down. So you have what's called convenience samples are almost guaranteed to show bias. So are what's called a voluntary response sample, in which people decide whether to join the sample in response to an open invitation. Okay, so voluntary response consists of people who choose themselves by responding to a general invitation. They're biased because people with strong opinions, often in the same direction, are most likely to respond. So there's a TV show called Dancing with the Stars, and that's the first thing that comes to mind here. Any of those shows where you have people calling in and casting votes, that would be a voluntary response. They feel very strongly that they want their contestant to win. Okay, it's a popularity contest, right? That's really what it is. They have a strong opinion. So the show Dancing with the Stars, a couple of years back, I don't know if anybody listens to the radio, probably not, but there's a show, Bobby Bones Show, and Bobby Bones won the whole show. He was just a terrible dancer. He was so bad. And every week me and my wife would watch it, and he might be in the bottom, but his voters would bail him out. They actually made a rule about it where if you were in the bottom, the judges would actually pick who left. And he literally won the whole show. He got the trophy and everything. So he shouldn't have won. He was not qualified for it. He was not that good of a dancer. But it was just biased because he had more people voting for him. So that's one example. Another example is this, and I know some of you work jobs. I know I have several students that work at Chick-fil-A that I've heard of. But there is and I worked at a restaurant, Bonefish Grill, during college, and a lot of you may have seen this before. When you get your receipt, sometimes there's a survey, and some people are like, "Hey, do you mind filling out this survey for us? We appreciate your feedback." Well, that would be an example of voluntary response. Because if you think about it, who are the people that are going to fill those out? Well, I asked some students in person, has anybody ever filled one of those out before? And they said, well, yeah, because I wanted a free sandwich, or it was like a free chicken biscuit. I don't know, just different things like that. But I said, okay, well, what if there was no reward? Would you ever do it? And they're like, well, no, definitely not. So at that point, who is going to fill them out? Well, it's going to be people with strong opinions. So at Bonefish, man, we would have like these big paragraphs of people like this. They would just be complaining about how it's dusty and the server didn't know what they were doing. The food came out too cold. No manager ever came by to talk to us. Obviously those are bad things, but it's just like this rant that's just so long. They had a really bad experience, and that's what, like, the higher ups, the corporate, they're going to see that. Or you have the other way, which means they just had like the best experience ever at like a restaurant or something like that. So usually the people in the middle who don't really care, they're not going to fill that out. You don't get a good representative sample. Only people with strong opinions are going to reply. So if you haven't written this yet, we'll pause and make sure you've got that. Okay, let's look at more examples here. So we have examples 2 through 4 here, where you're trying to decide, you're just reading the questions and deciding, is it biased, and what's the direction of bias? Okay, that's what we're trying to decide. So I'm going to pause the video. Go ahead and answer examples 2 through 4 on this one for me. Okay, so example 2, you want to know the average GPA of Stewart's Creek High School students. Sort of like heights, if you think about it, right? My sample consists of the students from my honor statistics class. What type of sample is this, and do you think the actual GPA of Stewart's Creek High School students will be higher or lower? So we're talking about, here's my sample, honor stats students. And we're interested, how is that going to compare to the actual GPA, the population, right? Like we said, if I sampled IM3 students, you guys would have higher heights than the true population. So what would happen here? Well, what kind of sample is this? You only have two options. It's convenience or it's voluntary response. Be convenience. And I always spell convenience wrong, so I'm going to cheat and copy and paste. We're going to do that. Convenience sample. What do we think is going to happen? These are these honor stat students and their GPAs compared to the entire schools. What do you think? Will the entire schools be higher than this stats class, or will it be lower? Well, if you think about it, these are honor stat students, and they're not going to be a representative sample of the school. They are students who are a little more motivated than the average student, truly, okay? Because a lot of the like standard math students would be in applied or bridge or something like that, and their GPAs on average are going to be a little bit lower. So Greek high school student GPA, like the population, would actually be lower, okay? That's really how that would end up. So I would say actual GPA of the actual GPA of students will be lower. Write that down. I'll put that here. There we go. The actual GPA of Steers Creek High School students will be lower because it should be. Okay, this is a biased sample. All right, American Idol, that is a TV show. It's a singing competition, and near the end of the season, you actually people can call in and cast their votes. Okay, this is a call-in poll. What type of sample is this? Well, you're only going to call if you feel motivated to call, right? This is very much like Dancing with the Stars. This is a voluntary response. That's the type of sample. Is this biased? Yes. Biased because only people who have strong opinions call in and vote for their favorite singer. Also, they can vote multiple times. That is something that happens to you. You get that double representation there that it also messes up with your data. Okay, that's a problem as well. Okay, and then example 4. This has had a lot. There's a lot to read here, and that's kind of how stats is, by the way. There's a lot of like reading, and it's very different from a typical math class. So. In May 2010, the LA City Council voted to ban most travel and contracts with the state of Arizona to protest Arizona's new immigration enforcement law. Los Angeles Times conducted an online poll that asked if the city council was right to pass a boycott of Arizona. The results showed that 96% of the 41,068 people in the sample said no. Does this result represent the opinions of all LA residents? Well, this is what you would call a voluntary response, right? This is an online poll. Okay? So this is a voluntary response. And really anyone could reply to this. It doesn't even matter the state, right? What if people from Arizona went online to this poll? Okay? People from Arizona would probably be pretty mad. And they would say, oh, no, they were not right. So they asked if the city council was right to pass this boycott. Well, if you're from Arizona and you see an online poll and you're angry about this, yeah, you can go in and say no. We don't have any idea how many of these 41,000 are actually from the city of Los Angeles. Is everyone in the sample from LA? Probably not. Okay? This is voluntary response. Only people with strong opinions will apply. strong. Mostly, I'll say mostly people with strong opinions will respond, and this survey is an open invitation there could be people in the sample not live in LA. Okay, that could happen. Okay, so how do we sample well? This is already in the sheet for you, but how do we sample well? Well, it's got to be random. You have to take a random sample. The use of chance is essential in well-designed sampling techniques. So this is, I would draw a line in your notes again and say, how do we sample well? So it says the most basic is the simple random sample. Okay? The most basic is a simple random sample. So let's pull up a note here. A simple random sample. So simple random sample of size, and we call the size in. I would actually like you to write anything highlighted, by the way, you're writing. Simple random sample, SRS of size n. N is your sample size. Go ahead and write that up. Is chosen in such a way that every group of n individuals in the population has an equal chance to be selected as the sample. So a lot of the distance learners have not seen me do this, but in class, like with in-person students, I'm always calling random people, okay? And if you have a teacher, I'm not gonna do any shots fired here, but a teacher is always concerned about how much their students know, right? A test is our best census, I would say, of how well the class understands material. But we don't want to wait till the test to figure that out. So we have to know during instruction and everything, how are students doing? How do they understand what's going on? So, teachers will say, hey, who can answer this question? Okay, and if students start raising their hands, that's voluntary response. We're not really getting good information when we have students just raise their hands to answer the question. Sometimes that's the right move, it's the right teacher move, but it's not always the best. Or if I want to call on somebody and I know someone better than others, or maybe I have an idea about who would know it, and I just pick somebody that's near me, or it's just convenient to get them to answer it correctly quickly, that's a convenient sample. But the true best method as a teacher to understand does everyone know what's going on, is to randomly pick them. So you've probably had teachers that use the little cup with the little popsicle sticks with names on it. I don't do that. I use a random number generator to do it, or a random name generator, because I've heard a story about a student will go in and take the popsicle without the teacher looking and throw it away, so they never get called on. It's pretty funny, but don't want that to happen, okay? Because they're sort of cheating themselves. But they'll be assigned a number, and I'll randomly pick. We'll talk about how to do that in a minute. But I want it to be random because I want every student to have an opportunity to understand and learn. So in class, that's sort of how I use random samples, but it really does take the bias out of it. You're not thinking anymore. Let's say that I numbered everybody 1 through 15, and then in my brain, I was like, okay, I'm going to pick a number. Well, that's still biased, right? On average, if I say, hey, pick a number between 1 and 10, if I ran an experiment, by the way, I would say most of you would pick 7. I'm just going to go ahead and put that out there. Most people aren't going to pick 1 or 10, okay? So it's very interesting how this idea of randomness, how us humans, we're kind of incapable of doing something randomly. It's just kind of impossible for us. So you've probably seen this with drawing names from a hat. different things like that. But we're going to be practicing, and we're getting pretty close to finishing here. In practice, people should use random numbers generated by a computer or a calculator to choose samples. If you don't have technology handy, you can use what's called a table of random digits. And that's what we're going to do to start this off. And then we will be using a calculator to do this, do the other part of it. So let's pull back up this sheet. And on the back of it, you will notice that here we go. It looks like this big matrix type thing, this table of random digits. Okay, that's what we're looking at. So we need to pick a survey here, or a sample survey here, a sample. The management company of a local mall plans to survey a random sample of, we want 3 stores to determine, I need to delete this by the way. Change that. Everybody watching this video, we're going to use line, let's just go with line 8 on the table of random digits. Change that. So it says use line 8 on the table of random digits to pick the sample. So we want to know, determine the hours they would like to stay open during the holiday season. So we have all these different stores here from a mall. Not that many people use malls anymore. It's all Amazon now. We're going to pick our sample. We're going to go to line 8. So let's go down here and we're going to find line 8. So let me draw. So we got 1, 2, 3, 4, 5, 6, 7, 8. So here is line 8. So we're going to be using that, this line right here. Turn it up again. And so let's talk about how this works. I go around, let's start with one number at a time and we'll get our sample. So 8, 2, and 4. Okay, so 8, 2, and 4. So let's start there. This is actually how not to do this correctly. So we're just going to put that out there. This would be going one number at a time, and let's look at that. So it's 8, 2, and 4. That would be Forever 21, All American Burger, and then Barnes and Noble. So what's the problem with going one at a time? Well, who couldn't get picked? Well, that would be 10 or after. I'm not going every 2 digits, so it's impossible. So when we're actually reading this table, we have to go 2 numbers at a time. So we start here with 82. Now, is 82 an option? It is not. So we skip it. Then we go 44. Is that an option? No, we skip it. 87 an option? No. 24? No. 30, and we're just going to keep going until we find one. 29. Here's our first one, 04, right? 04. 04 is Barnes & Noble. So we had that in our last one, but that is going to be one of our stores that gets sampled. Next, we skip the line here, 15. That is also a value. Let me correct that. 15. So 15, that is Old Navy. Then we have 92, and then we have 8. Okay, so 8 is the last one, so it's Forever 21. There's our sample of 3 stores. What had happened if we had the same one pop up again? Well, we would have to skip it. We can't have double representation of anything. So let's say that I got another 8 somewhere. Well, I can't use that. Okay, we're not allowed to use it. Like down here, let's say I got this 15 in. Let's say I was sampling like 10 of the stores and I got down to here and it was 15. I can't use that again because I already have it. So we're not going to be, can't double use them. Okay, so there's our survey. Now, to wrap things up, let's talk about what would happen or how you do this in a calculator. All right, so I've got both calculators up here, and this is how we're going to be randomly picking these values. So let's go ahead. We're gonna do the same thing again. I'm gonna change colors. We'll be green this time, and we're gonna pick a sample of 3 stores using technology. So let's start with the 80 series because I think most people have that. How we do this? If we press Math, then we go over to Probability and down to Random Integer, hit enter, have lower, so that's the lower boundary. So down here we have Aeropostale listed as number 1. So and the highest value for Zales is 21. So we put 21 here. Here in we said was sample size, so we're going to pick 1 for now. We can change that in a minute, but we hit paste. There we go. We get 20. Okay. Then we go over here to the Inspire, and we're going to type this. We're typing the same function, but you can use the keypad to do it. RANDINT 1. You hit this comma button down here. 21 and hit enter. Okay. Oh, look at that. We got the exact same thing. All right. Now what we can do is if we hit enter again, it's just going to keep generating random numbers. Over here, same thing. Hit enter. It's just going to keep generating random numbers. You guys see this? It's the exact same thing. That's suspicious, right? Is that actually random? Let's explain why this is happening. And by the way, we have our sample now. It's 24 and 11. That would be the sample that you should get. So 20, Vitamin World. We said 4, is that right? 4 and 11. So 4 is Barnes and Noble, and 11 is Hager. That's going to be our 3 stores that we would sample using our calculator. So why is this happening that they're the same? Well, it's because the calculators are working much like we just did. Random digit number. Okay. So they're reading a line, and they happen to be reading from the same table of random digits, and they're starting at the same line, just like how you guys working along with me, this 8th line, everybody should get the same random sample. So sometimes, like when I'm calling on students, I'll sit here and I'll hit enter for a little bit and I'll wait, because it repeats itself a lot of times, but you can get to a random place here. Okay, and in that way I'm pretty far down along the random digits table. Okay, so that idea, and that's why I wanted to introduce that table. You're like, wait, this seems very lame and old. It is. That's the original method that they used to get random samples, but I think it explains why we're seeing some overlap here. So something else you can do, if you go up and you with your pad here, if you hit enter, you can change this last digit to be another number, like let's say 5. And what that will do is, instead of sampling 1, you sample 5. By the way, if your calculator is a little bit older, you have to hit random int, and you got to use the comma here. So you'd want to type it in like this. Okay, hit enter. There's a sample of 5. Over here at the Inspire, I can just go in here, add a comma, which is down here, hit 5. They're going to be different this time because I've already used a lot on this right one. I've gone through several rows of that table. So okay, well that's going to be our lesson completed over random sampling. That is the first step in our designing studies section. Make sure you get this submitted onto Kidem. I've worked the whole thing, so you should have what you need.